let's give a scale. In Y, that's the thickness direction. We want to simply divide the thickness that determines the height of the box. So we would want the ratio between that thickness and the canonical profile's max thickness. And let's take a look. Now we have the scale that we're looking for. So scaling up and down. And the second scale would be in the Y direction according to the chord with respect to the length of this box. So the scale X would be the C root as compared with the profile's chord, which we know is 1. We update. Now we have the stretch that we're looking for. So now the profile is filling the wing as we would expect. And similarly for the tip, so the tip profile would also be a boxed curve, same curve in, the same canonical profile. The scale Y would be the same. The scale X should be according to the C tip. The center would now be the edge center right front instead of left front if we wanted at the front of the wing, the box. And orientation would be the same. So really, instead of repeating this expression, we could replace this with the root profile orientation. If we want to be explicit about the fact that the orientation of this one will follow the orientation of the root profile. Compile that and we zoom out and update, and there we have our tip profiles, and they look to be correct. So finally we can loft a surface. We'll just do the simplest case of lofted surface. Lofted surface does take several options, and sometimes we take steps to reduce the amount of control points or the amount of data in the curves going into a lofted surface as well. But for now, let's just make a loft, and it's of type lofted surface. And lofted surface takes curves, which is a list of curves, and that would be a list with the root profile and the tip profile. And that should be sufficient for a simple lofted surface. And there we have one, lofting out this way and lofting out this way. Now if we look at it from the top, the wing does not have any sweep at all. One way that we can give it a bit of sweep is to have this tip profile be at the rear of this box rather than aligned with the front edge of this box. So if we move it rearward by the difference between the C-tip and the width, we should be able to achieve that. So for the center on the tip profile, we could take this center and translate to the rear by the difference between the C root, which is the length of that box, and the C tip. So that has the effect of a bit of sweep, but the trailing edge does not have any sweep. The leading edge has a bit of sweep. It's really just the taper going back instead of forward, just depending on where we position this tip profile.